Okay, so how can we tackle this problem? We have this little green region here, which we call B, which is found between y equals 3x, the blue line, and the red curve y equals 3x squared. So if we spin the green region around the y equals x, the y equals 4 line, we're going to obtain an interesting solid of a revolution here. Great, so the first thing we need to figure out is just, well, a and b, right? So essentially I can say 3x squared is equal to 3x to figure out where they intersect. I can factor out a 3x here, so get x minus 1 equals 0, so x must be 0 or positive 1. So 0, or let me just quickly change the color here. So I got 0 and I got positive 1. Great. So what we also need to do though is figure out what f of x and g of x are. And how can we do that? Well, we need to take a look first at what our outer function is. The outer function will be, we're going to take a look at the y equals 3x squared here, but since we're revolving it around y equals 4, we're going to need to say that f of x is equal to 4, right? So we take the top and subtract the outer function, which is the 3x squared. The g of x will be 4 as well, right? So positive 4 minus this inner function, which is the 3x. Because once we spin it around, right, the 3, well, that's just getting horribly confusing, but the 3x is the inner boundary here of the solid. Great. So now I can essentially just plug everything into the integral, so I get pi times the integral from a to b, so 0 to 1, of 4 minus 3x squared minus g of x, which is 4 minus 3x squared dx. And that's it. So the answer is B.